So I think it's best to use the snip tool as our board. And so I copied the example thing to make it easier for myself. So when we're talking about 1D, well, we could talk about that, but that's so boring. Do I really need to talk about that? I guess I have to. So when we take a slice, so this is the x direction, this is the z direction, this is the y direction. We're talking about 1D heat, heat rod conduction. Heat is the transfer of energy, thermal energy. Heat is the transfer of thermal energy. That's the definition of it. So heat transfer is not the right word. I mean, it kind of is, but it's not. So what I'm saying is, a wrong definition would be a heat transfer of a heat transfer of thermal something. Like that'd be a wrong definition. You can't use that as a definition. Whatever, it doesn't matter. Anyway, we have this. So we start with this dx because we're gonna turn that into a small tiny disk later on when we do the definition of this whole thing, which is a painful definition, which is why I hate it, and you should hate it too. So there's a heat source, which is Q, and then there's a Q in out, which is gonna be the ddx, d flux, dt d flux. I believe that's dt, right? No, these dx. So yeah, you already got it wrong. It's a partial derivative, so we're gonna have a hard time. But we're not gonna actually put an equal sign. We're just gonna see a semi-equal sign, and we're just gonna put down that that could equal the that could equal something. That something is theta x parentheses t area plus theta x parentheses t area, but this also is wrong. It's actually the theta dx by the area, so the area can cancel out later on if you want to. Uh, I should do I put 8 in there actually? I don't really remember. I'm pretty sure we do. Um, yes, yes, we keep the area in just because so when we do a dE transfer of heat to the bond, we get something like I don't remember actually. It is E. So yeah. Oh yeah, I need to talk about that too. But um, E, we have an x dot t, but we also have a change in xa because that's the volume of the whole thing. So when we do the q everything, it cancels out to get some weird function of the time of E. Um, equal negative theta theta. You can look at that. I mean, it might be easier just to look at the textbook, and then plus the q x comma t. It might be easier to look at the textbook. Now I want to talk about something like a second derivative function. Why does this make sense to you guys? Um, well, the reason we have this thing is is uh, is due to laziness. One of them. We don't not laziness, efficiency. This just takes too long writing it like this, and this is here like a square because x is not x as a function. If I say x, a derivative of x, you have to that has to equal zero because uh, well you're putting input up like that. But if I was to put a function of y would equal x squared plus x or something like x equal ex or something different. So y f is a function and not the application use of a derivative. It's not part of the derivative, it's just a function, and we're applying the derivative to it. Therefore, it makes sense that that's not squared. This is why that this doesn't work. This doesn't make any sense. That, what are you talking about? That's a no. It's a void question. It doesn't really make sense unless you want a derivative of that, and after you want a derivative, you want a square of it for some reason, which I guess for some reason you could want, but why? I have no idea. You can estimate it yourself. It makes no sense to me why anyone would need it. Yeah. So